And it wants to start. There we go. So good morning, everyone. My name is Jesse, and I am with Exploring by the Seat of Your Pants. For those who don't know, we are all about bringing conservation, adventure, and science into classrooms around the world. Today, I'm really excited. We're joined by 6 classes from across North America, and I really do mean across North America. I'm going to give them a chance to do a bit of a shout out and then introduce our speaker. So we've got Miss Matson's 1112s in Green River, Wyoming. Hi, guys.
Hey, how's it going?
Yes, you guys are sufficiently deep with your voices. I love it. Okay, we've got Mr. Wright's grade 9s in Chatham, Ontario.
Hi, guys. Say hi. Hi.
Awesome. We've got Mr. England's 6 through 8s in Farmington, Missouri.
Hey, give it up.
Younger kids scream way louder. I love it. We've got Miss Fisher's grade 3s in Mishawaka, Indiana. Hi. Yes. And then they have to demute their own mics, but we've got Miss Piscatelli's grade 4s in Freehold Township in New Jersey. I think every hangout we do, we have someone from Freehold, which is very exciting. And then we have Mr. Lavogue's Conservatory School Group, K through 5 in North Palm Beach in Florida. Hi, guys.
What's up, dude?
I think you broke our mic. Okay. Of course, the reason you guys are all here today is for Dr. Daniel Wagner joining us from the NOAA, or National Oceanic and Atmospheric Administration Facility in Charleston, South Carolina. He is an expedition coordinator for their Ocean Exploration and Research Group, which means that he gets to man the trips, plan everything, oversee teams of scientists going to the coolest places in the world to do some of the most important research on Earth. I hope that's a good intro, Dr. Wagner. And without further ado, thanks so much for joining us, and take it away.
Excellent. So thank you so much for that wonderful introduction. I'm very excited to share with you guys today a little bit of the work that I do. So before I start, can you just confirm that you can see my slideshow now?
Yep, you're perfect.
And you can hear me loud and clear?
Loud and clear.
All right, wonderful. With that introduction, so I work for NOAA's Office of Ocean Exploration and Research. So just to give you folks a little bit of a background, I think NOAA, we're pretty well known, but we're mostly known for a lot of our weather forecasting, especially this time of year when we have a lot of hurricanes. So our agency does a lot of the weather predictions and forecasting and helps prepare people for storms and hurricanes. But our office also does many other different things. They manage the fisheries in U.S. waters. They also manage our waterways. And they also manage our sanctuaries, which are equivalent to our national parks, but in the ocean. So protecting some of our most special places on Earth. So my background, so I study coral reefs. I study corals. And I just wanted to give you a little bit of a sense of how I got into this field. So my story really started about 20 years ago when I was similar in age to some of you guys. And so I grew up, just a quick geography lesson, I grew up in a small country in Ecuador. So that's in South America. It's a small country right on the west coast of the South American continent. But what is very special about Ecuador is that it is home to one of the most wonderful places on Earth, known as the Galapagos Islands. The Galapagos Islands, for those of you who have never heard of them, they're really renowned because there were places where Charles Darwin, one of the most renowned biologists, studied and came up with some really groundbreaking theories that are still with us today. So I was very fortunate at a young age. I got to visit these islands, and I actually got to do an internship there. And one thing that is important to know about these islands is that they have a few islands where we have people and cities and are inhabited, but they have several other islands, a lot of these smaller islands that you see here, where you have no people and no people have ever lived there. And so I got to see these places. And one thing that even as a young child, I immediately saw is that how different nature was in these places where we did not have human beings. You'll see just an unbelievable abundance of life. A lot of these places you have small islands where when you try to walk on the island, basically every free space is taken up by birds, iguanas, other really beautiful and marvelous creatures. Same thing is in the ocean. We have massive aggregations there of fishes, of sharks, and it's truly a magical place. So that really got me thinking, even as a young kid, why is this place so different? Why do we have so many more animals? And also, the animals seem to be behaving very different than where I was used to. So I grew up in a city, but when I got to snorkel and walk in these waters, you see that animals were generally not afraid of me. You'd see a lot of things that were really curious. I saw one day we were going on a hike and a bird just landed on one of the guys that we were hiking with. When you go out in the water, you have these sea lions that basically swim up to you, and they're not afraid of you. They're generally curious. The basic take-home message here is that these animals are so much more abundant and curious because they have not learned to be afraid of us, and that's because there's no people. And that really inspired me to pursue a career in conservation and in biology and ocean exploration. So I was very fortunate that after going to visit these spectacular islands, I got to go to school in another pretty remarkable island group that is more familiar to most people in the United States, the Hawaiian Islands. So that's, of course, a big island group in the center of the Pacific Ocean. So you can see it here. That's a beautiful word shot, and you can see how isolated the Hawaiian Islands are. Very similar to what I explained in the Galapagos Islands. These are very far removed from many places where we have many people. And as a result, also their ecosystems look very different. And so here's another shot of the Hawaiian Islands. One thing that really changed my career path is that I started scuba diving at a young age, and it really fascinated me because you could look at the cities, you could look at streets, but as soon as you put your head underneath the water and look at what's underneath, you see some truly spectacular things. And in the Hawaiian Islands, we have some really spectacular coral reefs. So this is a picture of a coral reef in the Hawaiian Islands. So you see these things here that look like plants. So these are actually corals. This image really illustrates of why people are very interested in coral reefs. They are known as hotspots of biodiversity. So they create habitat for a lot of different species, for fishes, for lobsters, crabs, all kinds of things. And they are what people refer to as the rainforests of the deep sea, of the sea, because they have so much life and so much biodiversity. And that's why people are so interested in corals. So again, they create habitat for many things, not just corals. Where you see coral reefs, you typically see big aggregations of fish and other animals. And they're also very colorful. They're very beautiful to look at. And one important thing to notice about coral reefs is that, some of you guys that are a little bit older might have started to learn about photosynthesis. This is a process that plants do, and they basically allows plants to use energy from the sun and to transform that into energy that can be consumed into things that you can eat, basically. And corals actually, so this is a closed polyp. So they're the smallest pieces of life of the coral. So if you looked at them close up on a microscope, you would see all these tiny green circles, basically. And these are, in essence, are tiny plants that live within corals and that, as I mentioned, photosynthesize. So they actually use the energy of the sun, and then they provide nutrition to the coral. And so this is what we call a symbiosis, or living together when two organisms live together. And this is why corals in shallow waters are so successful and are able to create so much habitat for many different species. Now, one thing you probably will have heard at some point or will hear more in the future is what we refer to as coral bleaching. This living together of the corals and these tiny plants that live together. It's basically when conditions are good, this works great. But if conditions are not good, when it gets too hot or it gets too cold or there's diseases in water, these tiny plants actually get expelled. So they basically leave the coral, and that leaves the coral behind. And then all you could see is basically these translucent polyps, and what's underneath the polyps is the skeleton, and that's typically white. And so if conditions get too bad, it's too hot, we have what we call coral bleach. And this is something that's happening in many places throughout the world. And it's concerning in some places where you can have too warm temperatures and causing coral reefs to basically be stressed. Now, all that I said to you right now is actually just about coral reefs that are in shallow waters. So to about maybe 100 feet, 200 feet in some places where you have water clarity that's sufficient to allow sun to go through. What I haven't noted to you is that corals are actually found in all oceans, are actually found to extreme depths. And we've with submersibles and other vehicles, we've surveyed some of the deepest parts of the oceans, and we've actually found corals down to over 5 miles in depth, so over 8,000 meters. And these corals are, of course, in places where, because it's so deep, there is no sun anymore. The sun gets filtered out by the water, and it's basically completely dark. And if you don't bring lights with you, it'd be dark in perpetuity. But even at these extreme depths, we find corals. And these are what we call deep water corals or cold water corals, just because they are found in places where it's deep and cold. And important to mention about these deep water corals is that they are just as important as their shallow water counterparts. They're actually just as diverse. We have in deeper waters even more species of corals than we have in shallow waters. And they also create habitat for many different species. So just like in the shallow waters, at depth, when you see corals, you typically see fishes, crabs, other things, basically using these corals as habitat. You can see a couple little things that are hard to make out, but you typically see little invertebrates hanging on to these corals. So they provide important habitat. And just like in shallow waters, also in deep waters, we have coral reefs. So we have these massive structures where we have many corals living together. And just as their shallow water counterparts, they create habitat for a lot of life. And one important thing to note is that these deep water coral reefs, while they're very important, they create habitat for many species, we're still discovering them basically on every expedition where we go and look out for them. In fact, just about a month ago, there was an expedition just off the coast where I am, off South Carolina, and they uncovered what is believed to be one of the largest deep water coral reefs on the planet today. So this was a coral reef about 85 miles in length of continuous coral reef, at depths, tremendous depths. And you can see how much life there is, a lot of corals, you see fishes. And so, while they are very large in some places, we still know very, very little about them. And that's, of course, very exciting for people like myself, scientists that study these deep water reefs. But from the few studies that we've done, we've actually found some pretty remarkable things about a lot of these deep water corals. So this is a black coral, and this is actually a species that is found in the Hawaiian Islands. And you guys that are looking at these pictures are probably thinking that I'm completely insane, because that does not look like a black coral. You can see that this is quite red or brown in coloration. But corals, typically the common names we use, like black corals, come from the color that's what's underneath the tissues. And so these corals, if you were to remove all the tissues here, you would see what's underneath it, the skeleton, just like with us. And the skeleton of these corals is black in coloration. So this is, again, that same species. You can see there the black skeleton. Now, one important thing is that corals, or many groups of corals, if you were to look at the branches and the trunk of this coral in a cross section, so if I were to cut this in cross section and look under a microscope, you would see what we refer to as growth rings. So this is something that we also have, for example, in terrestrial trees. There have been many studies done for example, in California, where we have the redwood forests, where we have these very, very massive trees. You could cut one of those trees in cross section and look, and you would see that there's tiny bands, what we call growth rings. And if you know in what kind of periodicity these growth rings are formed, you can use that to age the trees. And just like we can do that with terrestrial trees, we can do that with corals. And that species I showed you right there, that black coral, we've done a couple studies on them and actually found that it's over 4,000 years old, that particular species. So that's right now is the oldest species that we know in the ocean. So truly remarkable. And that's also a common theme in the deep sea, is that because things, basically there's less food, it's dark, it's cold, things tend to grow a lot slower, and as a result live a lot longer. And that's truly remarkable that we have some species that are very, very old. Now, in addition to being very old, we have some species that, because they're so old, they can grow to extremely large sizes. This is another coral. This is a different group of corals, but also found in the deep sea. This picture here is taken about 3,000 feet. And this animal, it's hard to describe this with scale, like this just looks like a little whip to you, but this picture actually shows what is the largest coral known on the planet. This coral right here is actually over 18 feet in length. So this is basically the same size as an adult giraffe. So truly remarkable that some of these deep sea corals are extremely large. And just as remarkable as this, we actually just recently discovered this. So this was a study that was not done too long ago, where they came across this very, very large coral that is now known as one of the biggest on the planet. And coral reefs, I didn't mention this at the beginning, but so corals, when you see reefs, they're not just corals. There's big aggregations of all kinds of different animals. Typically, we also see sponges. So these are some of the simplest of all animals. You can see this. It looks very much like a sponge. This was a picture taken in Hawaii 3 years ago. And it's, again, very hard to get the scale here. But we put this now here next to the remotely operated vehicle. This vehicle here that was used to image this sponge is actually about the size of a small minivan. And you can see the sponge is just as big. And this discovery, when it was made, also was the biggest sponge ever known on the planet. So very recently, just a few years ago. And this is what makes my job very, very exciting, is that on almost every expedition, we come across something that has never been seen before, and something that's really remarkable, something that's not just never been seen before, but it's just unbelievable facts. And so I'm going to take the last part of my presentations to basically give you the opportunity, because I am currently in the process with a large team of other scientists to plan an expedition where we're going to be exploring some of these deep water ecosystems. And you guys will all be able to actually join us virtually via the internet on this exploration. So this is the ship that I currently work for. This is NOAA's ship, Oceanus Explorer. It's America's ship for ocean exploration. So this ship right here is fully dedicated. It spends about 6 months or so at sea, and it goes always to places that have not been explored and tries to go to go to places that no one has ever explored before and see what we see. And to do that, it's equipped with some really remarkable tools and equipment. It actually has two submersibles. These are what we call remotely operated vehicles because there's no people actually sitting in this when these things go in the water. All the driving of these submersibles is done from a joystick from the ship, so they can go real deep and explore some of these deep areas. Here's the close-up of this vehicle. It's a truly spectacular piece of equipment. It's equipped with all kinds of cameras. All around. It also has lights that allow us to illuminate the seafloor. There's several probes or sensors that allow us to collect data on different things like temperature or pressure. And then we also have these robotic arms, which allow us to collect samples if there's something that is particularly interesting to science. One important thing is that, I mentioned that the ship goes to places that have not been explored. And as a result, we end up operating in many places that have never been mapped. And this is something that many people are not aware of, that the vast majority of our oceans have actually not been mapped. And so we do that by basically, we have what we call echo sounders. So there's basically a little piece of equipment that's attached to the bottom of the ship that makes noise, basically, makes a sound impulse. That sound then travels through the water, goes down, and then when it hits the seafloor, it bounces or reflects off the seafloor, goes back to the ship, where we have basically a piece of equipment that can pick up that sound. And from when we make that sound and when it's received back at the ship, we can then calculate how deep it is. And by doing this kind of continuously, we can completely map the seafloor and get a sense for what's there. And so, yeah, on every expedition, we end up mapping places that have not been mapped. And what's truly remarkable about the ship is this piece of equipment right here on board. So we have a satellite dish, basically, and we use that to all the data that we collect. Actually, we stream live over the internet for scientists and the general public to basically be able to join us in real time. So this is just a little schematic. So we have the vehicles. They're tethered to the ship. So there's basically a wire. All the data from these vehicles is sent to the ship. That is then sent to satellite, and then that data goes basically to anywhere where we have an internet connection, and people can actually see exactly what we're seeing on the ship when we are many miles away from shore. So this is just an image from the ship. So I mentioned these are remotely operated vehicles. So there's pilots on the ship that drive these vehicles from the ship. So these are the screens that they see on the ship. They have all kinds of equipment that allows them to tell how deep they are, what's in the vicinity. So they have radars and other pieces of equipment. But as I mentioned, virtually all of this data is available to anyone. And so we stream this data. And so we have basically scientists from all over the world joining us on these expeditions and are able to see basically the same data. And we have people, just like you guys, a classroom also following along. So basically anyone can see these images from the seafloor via the internet. So it's a truly remarkable technology. So the expedition, we're actually just 3 weeks away, and we're going to be going to Puerto Rico and the U.S. Virgin Islands. So here's the map. So most people don't realize that Puerto Rico and the U.S. Virgin Islands are part of the United States and are actually one part of the United States oceans that's one of the least explored in the entire United States. And it's actually also one that contains some of the deepest waters we have in our oceans. So there's a massive trench that's north of Puerto Rico that's never been explored, the deepest parts. And so we're going to be exploring some of these places, and you guys all get to join remotely. So we'll be doing a few dives basically to look for these deep coral reefs, similar to what I talked about in the beginning of the presentation. We know of some coral reefs that exist in the region, and so we are planning some dives to try to see how extensive they are. We're also planning some dives to study the geology. As I mentioned, some of the deepest waters in the entire Atlantic are actually off northern Puerto Rico, and so we'll be doing some of the first ever dives in that area. And we'll also be doing a few dives, not just looking what's on the seafloor, but also looking at what's in the water column. So this is a group of animals. So the water column, if we think about it, what's not associated with the seafloor, but all the water that's above that, it's actually the largest habitat on Earth. There's many, many thousands of species that are there, and we know almost nothing about them because these are animals that are very, very difficult to study. Now, a lot of these are quite fragile and gelatinous. So if you were to drag a net, these things would completely disintegrate. So we know almost nothing about it. So we'll be imaging a lot of these animals that we know virtually nothing about. And then, as I mentioned, we'll be doing quite a bit of mapping. We know there's many shipwrecks that were lost in this area. And if we get lucky, we'll hope to see some of these through our mapping data. So there's many different themes that we'll be exploring on this expedition. So I just wanted to share how you guys can all participate. So just like you guys are watching this over a YouTube channel, we also have a YouTube channel for all of you guys to follow. We will have dives every day, starting on Halloween, down to 2 days before Thanksgiving. We also have an expedition website and several social media accounts that you guys can actually follow all that's happening, get updates of what's happening every day. So our expedition website, I have the link here on all the slides. One thing I did want to point out for all of you students and your teachers is on our website, we actually have an education tab there. And there is many, many different resources that are available to all of you. There are interesting facts, there's lessons, highlight videos, all kinds of different things that you guys can use in the classroom and at home to explore some of these truly remarkable habitats. And here, I asked Joe to disseminate a flyer that has all these links. If not, this link right here can basically take you to all of these things. But over the next 3 weeks, we'll be exploring these areas, and you guys all get to join in real time. And with that, I'd open it up for questions. I hope I get to answer all of your questions, but if I don't have time, I also have my email there, so please feel free to reach out if there's other questions, and thank you so much for joining us today.
Very cool, Dr. Wagner. That was outstanding. And so we will pass along all those links to the classes. I think Joe's already sent it the newsletter, but I can pass them along in an email the moment we're done. That was outstanding. And yeah, let's go to questions. I know Miss Matson's class needs to leave fairly soon, so we're going to go to them first. And if you guys want to kick us off with 2 questions, then we can go to the other classes right after.
You guys have questions? Okay.
How do you fund for all this?
How do you
Fund it.
Funding.
How do we fund it? How do you fund it, Dr. Wagner?
So we are funded by the U.S. government. So NOAA is part of it's a federal agency, and we, as I mentioned at the beginning, we do a whole bunch of different things from weather forecasting. So yeah, the U.S. government is funding part of this. But ocean exploration more broadly, there's different avenues that are used to fund this. Now there's also universities, and the private sector has a part. Yeah, so different resources are used to fund this.
Excellent. A quick note for you, Dr. Wagner. Your video isn't working. Your audio is. We can hear you, but we can't see you. No worries if that's the case. Just try and work on that if you can. Miss Matson's class. There you go. You're back. Miss Matson's class, if you guys have a second question, go right ahead.
I have a question about the coral rings. So can you tell in those coral rings, like in trees, when the coral has been stressed or when there's a time that maybe in the past the life of the coral that the ecosystem wasn't as in good of condition so that it grew well or didn't grow well?
Yeah, so that's an excellent question. So I mentioned that corals are very long-lived, and as a result, they can record within their skeletons, within their tissues, potentially information about past conditions. And this is what we call paleoclimate studies, and corals are used to that to get basically at information of what were temperatures in the past, what was the ocean chemistry in the past. And it's a very, very hot topic of research. And it's one of the many reasons why people are so interested in corals is because we cannot just learn something about the health of the reefs today, but also about very, very looking into the past, potentially several thousand years ago.
Very cool. Before we go to our next class live on screen, I just want to note that we have several groups watching live on YouTube. If you guys want to pass along questions in the chat bar on the right, I can pass them to Dr. Wagner. So please do go right ahead and do that. But in the meantime, let us go to Mr. Wright's class. You guys have a question? Yep, you're good.
How many countries have you studied coral reef?
Yeah.
And do you think megalodons still exist?
Did you hear that okay?
I think I got the first part of the question of how many countries.
Yeah.
I was asking how many countries have you studied coral reefs in? And the second portion was, do you think megalodons still exist in the ocean?
So start with the countries. I still don't think, I didn't quite get to the second one, so I don't know whether it's not coming through or it's just you're a little too far from the camera.
The second portion is asking if megalodons still exist in the ocean, or do you think they still do?
Okay.
I couldn't.
Start. Here, guys, type it in. Mr. Wright's class, type it. Is it megalodon? Are you asking about megalodon?
Yes, that's what he's asking.
Okay, good. So, Dr. Wagner, how many countries have you been to, and does megalodon still exist in the oceans?
So first part, I'd have to guess. Yeah, I would guess around 40, 50 countries. So with ocean exploration, we've actually gone to quite a few different countries because the ocean, there's so many different places. I also just privately, I have an interest and passion to travel, and so that's bumped up. And then about megalodon, so that's an interesting question. So actually, there are these what we call giant sharks. And where I was in Hawaii, I worked with a museum out there, and they in the earlies actually on nets got a megamouth shark. To date, there's only been 3 of them found and captured. They are enormous sharks. They're now the interesting thing about these sharks is they don't have the vicious teeth like you would expect from megalodon. But megalodon teeth, actually, where I'm out here in South Carolina, you can still find remnants of their teeth in many places if you go scuba diving in some of the shallow water estuaries. But yeah, unfortunately, megalodon is extinct.
It is very unfortunate. We get this question a lot. We wish there were megalodon left. Alas, we haven't found any yet. Unlikely to either. Let's go to Miss Fisher's class. You guys have a question? Go right ahead.
All right. Yeah. Go ahead and ask a question. What tools do you use to explore underwater?
Excellent question. So we use, I talked about some of them. So we, because we go so deep, it's basically too deep for people to go scuba diving. So we use robots. And I showed a few pictures of these robots. And for those robots to basically to collect the data that we're interested in, we need equip them with all kinds of different things. There's lights on them so that we can see. There's cameras so that we can capture video and images. And there's all kinds of sensors that basically allow us to measure things like temperature and other things that are relevant to the environment.
Excellent. All right. Miss Piscatelli, I actually can demute you now, so if you guys have a question, come on up.
Okay, go ahead, Day. Can you guys turn our lights on? Zoe, quick, run, turn the lights on. All right, Day, you have to come right up to the microphone. Okay, go ahead.
My question is, which bodies of water do you usually explore?
So excellent question. So I was talking about the ship that I work for, NOAA Ship Oceanus Explorer. So it is currently in the Atlantic Ocean. Now this ship basically, it's fully dedicated to ocean exploration, and it's been in all of the major ocean bodies of water. So it's been in the Pacific, it's been in the Indian Ocean, and in the Atlantic. Now, typically, the way we plan these large campaigns or field campaigns is that because distances are so large in the ocean, we typically focus on a particular place on Earth for a few years, and then we move on. And so now this ship will be in the Atlantic for the next couple of years.
Cool. All right, let's go to Mr. England's class. You guys do need to demute your own mic now, so just come on up to the front, a little microphone symbol, and then you're good to go. Yep, okay. Perfect.
All right.
All right. Have you studied the impact of ocean acidification on creatures in the deep sea, and what changes have you noticed?
So that's an excellent question. So for those of you who are not familiar with it, so I talked quite a bit about warming temperatures, and that being a problem with some of the shallow water coral reefs, them becoming bleached. Another impact that we're having because we're putting a lot of carbon dioxide in the atmosphere is that some of that carbon dioxide eventually makes it into the ocean, and as a result changes the chemistry of the ocean and basically makes the water more acidic. There are changes that we are seeing, and in fact, deep water coral reefs are some of the most vulnerable to ocean acidification. It's fairly complex chemistry, but typically, if you were to measure the chemistry of the water going deeper, there's basically a particular depth below which conditions are too unfavorable for coral reefs to exist. It's basically not good. And what's happening is that depth is getting shallower and shallower as we're putting more carbon dioxide in the atmosphere. And so there are studies that are looking at this. And basically what we're doing is we are slowly eliminating some of these deep water coral reefs. And that's, of course, a cause for concern. But it's a very active area of research.
All right, let's go to Mr. Laveau's class, who I can also do. So if you guys have a question, come on up. Yeah. Oh, you're good. Yeah.
Hi, I'm Amelie. I'm Amelie, and I'm in 5th grade. And what's the most interesting thing that you've seen while you were diving?
So I will take you back to when I was actually in graduate school. And so I talked about scuba diving, and I did this in the Hawaiian Islands. And now the Hawaiian Islands are an area where humpback whales come for certain months a year. And so I was scuba diving, and all of a sudden I looked up, and it looked like a massive bus was coming my way, and it was a school of humpback whales. And I got to scuba dive with them for about half an hour or so, and truly magical to see animals of that size.
Yeah. Wow. Very cool. All right, let's go back to Mr. Wright's class.
We're in Toronto or actually, I think they have little. They only have. Some of the bigger ones.
Come back to you guys in a second. Miss Fisher's class will go to.
All right. Brianna, come on up. Ask your question, dear.
Do other scientists work with other scientists?
Say it louder.
Do you work with other scientists?
Excellent question. So, I mentioned that when we go on these expeditions, we stream all the data via the internet for you guys to see and for other scientists to see. And it's actually an extremely collaborative approach. On any one of these expeditions, we can have up to 200 scientists participating. In fact, this expedition that I'm talking about that I'm going to be going in 3 weeks, all the areas where we're going to be going were proposed by other scientists. And so we basically try to get input from the scientific community. And it's highly collaborative. So we work with many scientists, and it's not just nice. I mean, I love working with teams, but it's also absolutely essential because there's so much to study and so much to learn. And just by having large teams, specialized scientists that work on different fields, by working together is the only way that we're going to be able to understand this enormous area that's the deep sea. But yeah, excellent question. And that's, I think, important for all of you guys in school is, working together is really an important skill in many fields.
Very cool. All right. We're getting close to lunchtime for a few classes. So we're going to do 2 more quick questions, and then we'll wrap it up there. So we'll start with Mr. Laveau's class. You guys have a second question? Come on up.
Yes.
Yep.
All right. Sorry, go ahead.
Hi, I'm Elliot. Where do you want to dive that you haven't been to yet?
Ooh, excellent question. So in terms of scuba diving, one place that is for those people that scuba dive is kind of the ultimate place is in Indonesia. These are places where we have the highest diversity of corals on the planet. It's a place that I've never been to. If in terms of real deep diving, actually the poles, if I were to decide where I'd want to go take a submersible, both the poles are the North and South Pole are places that I'd love to go to sometime in the future.
Very cool. All right, and we'll wrap it up with one last one from Mr. England's class. If you guys have a question, come on up.
My name is Nora, and I'm written down, how long does it take for a coral reef to grow, and can damaged coral reefs grow back?
So that's an excellent question, Nora. So it changes. Obviously, there's different species of corals and different. Some grow faster, some grow slower. So I talked about some of these deep water coral reefs, and I showed you those images, and I talked about that one reef that's over 85 miles long. Reefs of that depth of those species have been dated to be over 10,000 years old. So that means that it took 10,000 years for this to establish itself. So if you were to damage it, it'd probably take at least that long to recover. So that's a really important lesson for us because these are very slow growing and long lived. If they are impacted, it takes a very, very long time for them to recover. In shallow waters, actually, I showed some of this picture with scuba diving, there are reefs that have been dated also to several thousand years. Now, those are reefs that are typically, we have species that are a little bit faster growing, but still they grow slowly, and it takes a long time for these massive reefs to form. So same kind of thing. It takes a long time for them to recover.
All right. And then before we wrap up, so Dr. Wagner, is there any last message you want to share about the expedition coming up? Anything about coral reefs? Anything you want to say before we wrap up?
Well, yeah, so I hope that you guys get to join us on this expedition and tune in on a few of the dives. And then just, I guess, for all of you guys that love the ocean and love the outdoors, just encourage you to go outside and take a look at There's so much to explore, not just in the deep oceans, but everywhere around us. I encourage you guys to follow the things that you guys like.
Very cool. All right. At the end of every presentation, what we do is demute everyone's microphone. So Ms. Fisher's class, Mr. Laveau's class, Mr. England's class, if you guys could join me in saying a big thank you to Dr. Wagner for joining us today. So thank you so much.
Thank you.
Awesome. All right, we'll be doing coral reefs all month long. Dr. Wagner, I'm going to pass along those links to the classes. We look forward to having you back personally, colleagues of yours at NOAA, whenever you guys would like. And till then, everyone, have a wonderful rest of your day.